Jordan, you good? Huh? Okay. All right, so click on Generate Members. Or somebody remind me to email the file for this after. All right, and start off and click on Joint 1. And then you'll have a line attached to your cursor there. All right, and click on Joint 5, then Joint 9, then Joint 13. Okay, and just go up to the line. And then after you click on 13, right click. You good, Logan? When you right click, you'll have a yellow line. And then go back and hit Generate Members again. And do the same thing for 2, 6, 10, 14, and right click. And the same thing for 3, 7, 11, 15, right click. 4, 8, 12, 16, right click.
You always do columns?
Huh?
You always do columns?
You can do whatever you want to. I mean, I just picked to do columns first. All right. So what I did is I just created 12 columns using W14 by 74s out of steel. I mean, you could put W14 by 74s out of concrete, but they don't make those. So make sure you got the right material property when you do this. So once you do that, go ahead and click on Store at the bottom right corner. All right, and then we need to place the beams. So you're going to go back to the section property group up at the top right, and you're going to click on the W24 by 117 and hit Done. And everything else should have stayed the same. You're going to generate members and start at 5. And if I go too fast, tell me. You okay? So click on 5, 6, 7, 8, right click, generate members again, 9, 10, 11, 12, right click, generate members, 13, 14, 15, 16, right click, and then store. All right, so we just created this frame in STRUDL. Now you have a maximum on your version of 50 nodes and I think 200 members. So make sure if you're ever doing a model that you don't make it too big. You get done with it and then it won't let you save it. And for future reference, anybody that's doing senior design, I have 4 copies of this, the full version of STRUDL now, that for the department to use. All right, so now that I've got that, if you click on View, the View tab right here, up at the top, and let's click on Isometric View. You get an isometric view of the frame, and click on Redraw Solid. What does it look like? You click on Redraw Solid. All right, you can see the beams and everything. Okay. Now, this is a good way to make sure that you got your beams rotated in the right direction. Okay, so from your columns and stuff. So, for example, instead of having square columns right here, we actually have wide flange sections that look like that are in this orientation. Now, if I rotated those 90 degrees for my columns, is that going to affect how my frame behaves? Why is it?
Because you're using the weak axis of the member to resist the one member.
All right, so when you're doing this, you want to make sure that if you were to rotate it, all right, so you want to make sure that your columns are oriented correctly to be in strong axis bending in your lateral resisting frame. All right, now there may be a situation though in the other direction, because we're not going to do it today, but at some place in this building, you've also got to account for wind blowing either this way or this way. All right, so we got to put that in there too. But anyway, so I just wanted you to see what the model looks like, and if for some reason you forget and you left your units in inches, that would be a big blob of just members connected, because they would be huge with respect to the lengths. All right, so it gives you another way to look and make sure you type everything in right. All right, so go back to XY plane here. All right, and this will be your frame. Now we need to add some supports to the bottom. So we're going to go to Create, and you're going to click on Support and Release, and then we're going to click on Create Supports in the top right corner, and you're going to click on joints 1, 2, 3, and 4, and then right click. Now, the default in this program, and probably SAP or STAT or anything else, is that when you click on them to make them a support, they're rigid in every direction. Rotation, displacement, everything. Okay, but we want to release the moment about the z-axis. So we want to allow these joints to rotate this way because it's extremely difficult to have a true fixed connection at the base of a building. All right, so we want to click on release MZ and then click done. And that gives us our what you call boundary conditions for a model. Okay, now, so this is my model, but I need to save this before something happens. So go to File, and you'll see something that says Generate GT STRUDL Text Input. Click on that, and you should get this window that pops up. And click on Generate Input File at the bottom. And let's see here. All right, and you want to save that file. It should be it's .gti, and all it is a text file. Okay, and then hit done. All right, so that saves all the geometry we just put in. Now we gotta apply our loadings. So what we're gonna do now is we're gonna go to Create, Loads, and you'll see a drop down that says Active Independent Loadings. Okay, and you want to click on that, and you'll get another dialog box. Now this is where you're gonna put in your wind loads, your live loads, your dead loads, your snow loads. Right, and this is where they have to be in kips per foot. All right, so to start off with, let's do the live load to start off with. So if we're at 40 PSF, we said our tributary width on that building is 10 feet for that frame, right? Okay, so that says that our live load is 0.4 kips per foot. Okay, so we're going to type in a capital L for the name, and then we're going to put live load under description. And I'm going to click Store New, and you'll see it pop up. Okay, now we want to go in and we want to apply these loadings. Now I want to read you something out of here. And if you didn't bring this, it's okay, but try to start bringing it in the future. I want to read you something in the live load section here. All right, if you look on page 13, and this goes into the influence lines and stuff we talked about last week. On page 13, in section 4.3.3, it's got a section that says partial load. It says the full intensity of the appropriately reduced live load applied only to a portion of the structure or member shall be accounted for if it produces a more unfavorable load effect than the same intensity applied over the full structure or member. So what does that mean? What did that just tell you? So for example, what's the worst case place to put the live load for this beam right here? Over the whole thing? Is it just over that beam? I think pattern live loads. Pattern live loads.